All right, so let's continue. The second question reads, the Venn diagram below shows the number of girls and the colors they like. So whatever will be given here, just know that it's about girls and the colors they like. And the colors they are mentioned here, blue, red, and yellow. So the assumption is that B will represent blue, R red, and Y yellow. Now, the question says find the number of girls who like blue. Just blue. Well, since blue represents the number of girls who like blue, we'll just sum everything that is contained inside B. And when we add here, 2, 5, 4, and 3 should give us a total number. So when we add 3 plus 2, that's 5, plus 5, which is 10, plus 4, which is 14. Hence, the number of girls who like blue is 14. Then B says both blue and red. So that's both blue and red. Now, here are some terms which we have to understand. Both is the same as somebody telling you or. And or, both, these, they mean union in sets. So both blue and red. Then and means intersection. So what they basically mean here, we want to find the number of girls who like, they like blue and they like red. Those who like blue and those who like red. Not that these are people who like both, no, but want those who come from the blue set and those who come from the red set, then we sum them up. So find the sum of those who like blue, then we add the sum of those who like red. So now to avoid double counting, so say B plus A minus B intersection, B plus R minus B intersection R. So the reason why we're subtracting the intersection is because we are trying to avoid double counting. Because if we get those who like blue, it means these, the intersection, would have already counted them. So we know that the total number of those who like blue, they are 14. And we just add those who like red. Now, the number of those who like red, they are 9 plus 11, that will give us 20, plus 5, that will give us 25, plus 2, 27. So the easiest way, instead of you adding and subtracting the intersection, just get the summation of those who like blue, which is 14, plus those who are not attached to blue but like red. So that's 20. That's 9 plus 11, which is 20. So this will be 14 plus 20. And 14 plus 20 will give you the number of those who like blue and red. So when you sum this up, so that should give 14 plus 20 should give you 34. So that's the number of people who like blue and red. So 30. Pardon my pen here. This should be 34. All right. Yeah. So we should have a 34. This is a 4. Yes. Red and yellow, but not blue. Wow. So red and yellow, but not blue. So red and yellow. Remember that and will mean intersection. So red and yellow simply means R intersection Y. And R intersection Y, that's 5 and 11, which is 16. But not blue, meaning they don't like blue, or we don't include blue. So we'll subtract, we'll find the intersection. After finding this intersection, we'll subtract those who like blue, which is the 5 here. So simply what we're remaining with is 11. So red and yellow, but not blue, it's 11. So red and yellow, it's 5 plus 11, but not blue. So remove those who like blue. So we remain with 11. And last but not the least, well, this actually is what I would encourage you to start with. Okay, so let me first indicate here that we have 11. Then the last one, all the three sets. You just look at where they intersect. So you've got a 5 here. This is shows where these all three sets intersect. So these people, they liked all the three colors, and you indicate that it's 5. But if we had a number outside of these three sets, so a question, I might include a question, or another person might include the question to say those who didn't like any of the colors. So you look at the number that's outside these three sets. And also a question might also be included to say find the total number of those who were interviewed. Let's say this was an interview, so you just sum everything up. If there was a number outside, you also add it. That will give you the total. So all right, I think we're done with sets. This was the last question on sets.